Oh my gosh. I was on the wrong account when I guess I signed out or something. And I was on the wrong account. Oh my gosh. It was set back to zero. And what all that work we did together was set back to zero. I was on the wrong account. So anyway, let's dive into some functional programming with Python. Guys, we are on the recursion bit. Recursion, that is a fun thing. So recursion, from bird's eye understanding, I'm not the best at data structures and algorithms. I'm solid at them, not the best. Recursion is us using a function within itself to do more functional bits within itself. So it's a really interesting meta concept. Let's dive in. Recursion is a famously tricky concept to grasp, but it's honestly quite simple. Ooh, that's an oxymoron. It's tricky but simple. Don't let it intimidate you. A recursive function is just a function that calls itself. There we go. So recursion is the process of defining something in terms of itself. Weird. It's a Russian doll thing, where you pop the Russian doll thing off and there's another little Russian thing in there. I don't know if you guys have seen Toy Story also with the, yeah. So I'm trying to get back into the thing, the thick of this, or the thrive of this, because I just did a polygonmatic Mumbai testnet deal, and it was pretty fun. It was a fun little tutorial. So check that out if you like blockchain stuff. But let's get into recursion a little bit more. Okay, so if you thought loops were the only way to iterate over a list, you were wrong. Wrong. Recursion is fundamental in functional programming because it's how we iterate over lists while avoiding stateful loops. Take a look at this function that sums numbers into a list. Okay, so let's look. So we have a summation function. Just checks if the length of the list is zero, just returns zero. Just a quick check. And it returns num0 plus the function itself right here, the sum of all the numbers after zero. Huh, isn't that interesting? So it takes the numbers, and this still somehow adds the 0th number, add the first number to the sum of the rest of the numbers. Isn't that interesting? So it would build a nest of numbers. An array would pass, the next array would pass into numbers would be actually the array at the first element, which would now be the new 0th element. So that is cool. So let's kind of break this down in real terms, right? So if we have a bunch of numbers, what it passes in is it's saying add the 0th number, so 2, right? If the nums array is this, let's pretend sum is this, right? If we print it, I'm sure it would show us what we need to see, but we don't need to. I just want to show conceptually what's going on. So this position would take the 0th element, which is equal to 2, and it would add the sums, the sum of the nums function, starting with the first element, this second go about, which would be this array. So that's what that means. The 1 colon, it would take this array, and then the 0th element would then be 3. So then right now it would say 2 plus 3. That is so cool. And then it would take in this next array at the first element, which would be 54. And we want the 0th element of that, right? Plus the 0th element of it. It's such a cool thing, right? Which is 6, right? So then plus, the 0th element of 1. That's pretty cool. That is pretty cool if you think about it this way, right? Right? So that's kind of what I'm seeing this function look like. So the 0th element of all these things, and then pass it back through and lob off the 0th element. Start with the first element. So cheeky. Just cool stuff, right? Okay, so let's keep reading. So base case, the base case of a recursive function is the part of the function that does not call itself. It's what stops the insanity. Without a base case, a recursive function would call itself forever. So that's why we needed this bit. Okay, got it. So we need a stopping point, basically. Something that says, done. Okay, so without that, boom, it would call itself forever, and we don't want that. In this example, we want, once the list is empty, we know we've reached the end of the list. So we need a base case every time. That's good to know. So solve a small problem. Okay, so that was a small problem. And then okay, so it's saying we solved the small problem, so just addition of numbers. And then the recursion bit, we actually need to put some deeper thought in. So finally, we actually need to call that function again, but with a more constrained input. In this case, we call the sum the numbers list except the first one. I thought this was actually, yeah, okay, that does make sense. Yeah, okay, great. Awesome. So the assignment, doc to doc, we want to do a factorial bit. So factorial R, I imagine R is just some number. We need to do some factorial stuff. So if x equals 0, maybe return, right? Return 1, I bet is kind of going to be what we want, right? Because we don't want to multiply by 0, because if we multiply by 0, the whole thing will be 0. So let's say we want x times, would it be x minus 1, right? But I'm not sure, guys. Let's see. Would it be this? X times x factor. Oh, no way. First take Drake, baby. Let's go. That's fun. That was fun, I should say. I'm not gonna say it's gonna be fun, but that was fun. That was a good time. Okay, cool. So I think that makes sense in my brain, because if we pass in 5 here, we're gonna say 5 times 5 minus 1, which is just gonna be 5 times 4, 5 times 3, 5 times 2, 5 times 1, all the way down to 0. Once we get to 0, return 1, because we do not want to multiply by 0. What happens if a recursive function has no base case? It will cause itself forever. So what is printed if I call print characters elephant 3? Well, let's take a look, see. Okay, so print characters elephant 3. So we're going to print the word if I equals the length of the word, return. So would it print 1, 0, 1, 2, 3? So it starts at P. P is going to be in there. We do know that. So anything without P in there, we could just, I think, get rid of, right? I don't think it's going to be and, not going to be that one, not going to be this one. So it's going to be 1 or 3, I think, or A or C. Now, which direction, right? So if we pass in 3, what would it do? It would print the word I plus 1. So 3 plus 1. Oh, okay. So then it'd be fent, right? Because it would go from third index and then keep recursively going upwards in the index. Okay, cool. Zip map. Fun. Let's practice another simple recursive function. Simple. Keyword. Simple. Okay, so within doc to doc, we need to map certain properties from one document to properties of another document. Complete the recursive zip map function. It takes 2 lists of equal length. That keeps it easy. And returns a dictionary where the list provides the keys and the second list provides the values. So we have 1, 4, 2, 5, 6, 6, 3, or 3, 6. So it looks like that. An object after it, or a dictionary after. So steps here, if either keys values length is 0, just return an empty dictionary. So that's our base case. So let's say if keys or values, we could say length of these equals 0 or length of these equals 0. We could return an empty dict, right? So that handles that, I think. Recursively call zip map on all. Well, let's think about this, right? Do we need an empty object then, like an empty dictionary? So we'll say init dictionary, right? Maybe we could just return the init dictionary, initial dictionary, right? Else we want to return. Let's see. We want. How do we append keys in map? So do we need to loop through it? So add the first element of the keys in the resulting dictionary and add the second element. Okay. So for key in keys, maybe, right? We want to take initial dictionary and say, is it just add? I always forget with the dictionaries, right? So Python add to dictionary. Is it add or append? Add or append, add or append, add or append, or you just actually put in a thing like this. Okay, so that's updating the, oh, good to know. So we could use that for maybe updating the key values. So this will just add this dict color. So maybe we could say this dict equals maybe values at the same index, right? Maybe would that actually work? So if, let's see, so if I said length of keys, so 0 to length of keys for key index, would that potentially work? Maybe. Is this how you do key indexing with loops in Python? Is the question. It's a great question. It's a great question, right? Then I don't even think technically we need to recursively go through this, to be honest. Maybe. Is this one way to do it, right? Is it? No, we can't do that. So if we go length of, or is this how you write loops in the old Python world, right? So length of keys, this key index. I want to see if this works. I am going to throw it in the old Chatteroo GTPs and see what we have here. Let's see. Because that would actually be really cheeky. I like that a little bit more than recursion, right? Let's see if that'll work. Key values. I don't know if that works. That does work. And we don't have to, we actually use the zip function here. Okay, let's not cheat. Let's see their solution. So they do a zip map with the keys, cutting off the 1, returning the result. Let's see. So how does that work? Does this automatically make an object? That's a cheeky way to do it. Okay, so we can return an initial dictionary, right? The result is the zip map of the keys cutting 1 off. Okay, let's see if I remember this, right? So the result is the zip map of the keys cutting 1 off. So we do this, cutting 1 off, values, cutting 1 off. So that seems to be kind of a common pattern here. And then it looks like the key is keys at 0, I believe, and then values at 0, something like this, right? Return res. Let's take a look. Oh, the res, okay, the result is the keys of the values here. Now, I don't understand this, to be honest. I'm not fully understanding this bit. So the result is taking the 0th key, mapping it to the 0th value, returning the result. And this is the whole dictionary. Okay, let's try it from scratch, folks. I know it's roughly fresh in my brain, but we got to try from scratch. So if length of keys is 0 or length of values equals 0, return dictionary, else we have this key deal. So we have result equals the zip map of the keys, slice one off, and the values, slice 1 off. So this is the base case, so we need it to come all the way down to the 0th length, right? And the result of the keys at the 0th position is the value at the 0th position. And we just return that result. Okay, no, oops, missed something here. Line 4, zip map keys, values. Now what is going on here? So the result is this. What did we miss, folks? What did I miss? What did I do? So the string, trace back, call last. So right here, the length of values or the length of the keys is 0, return empty object. Else append result to the zip map of keys and values. No. To be this. What did I miss? Result equals the zip map keys, the value. Oh, it's on the wrong side of the. There it is. Okay. What line contains the base case? So it's going to be this one, print that. Which line has the recursive call to countdown in -1? What would happen if we swap down the countdown in -1 for countdown in? I don't think anything. The code would just do nothing. It would just keep calling. So sweet. Okay. Where are we at? Where are we at on recursion? Wow, cruising right through, guys. Super fun. Okay, so recursion on a tree. Recursion is often used in tree-like structures because you can go down the branches very quick. So for example, it's often used to iterate over nested Python dictionaries classes that link to one another or files in a nested directory system. Assignment. You're responsible for a module in doc2doc that can scan a file system represented in our code as nested dictionaries and list all the files by appending them to a list. So complete the recursion of this. Interesting. This one's going to hurt my brain. It already hurts. Okay, so complete the recursive list files function. It accepts two arguments, the current node, the dictionary, the current path, a string. So the node is the dictionary. Okay, so it should return a list of file paths. Use a / character to separate the dictionaries in the path, including the root. For example, documents / proposals. Okay. So I really just want to see what we're working with real quick when we say current node and even current path. What do they start us out with, right? So the node is this object and the path is none, it looks like. It's empty. So we get this actual object and we want to take the 0th key, I believe, which would be documents. Expecting, where is our node? Where is it? Oh, I don't see it. Maybe, can you not take the 0th key in a current node or in a dictionary? How do you get the first key, right? Is it not just the 0th deal? I don't see it. I don't see it. I don't see it. Okay, so if we make this a string and then split it at the colon, would that work? Create an empty list to store file paths. Okay, so that'll help. Let's say paths, right? For each node in the current dictionary, feel free to use a loop. Okay, so for, we'll say item in current node. Let's print the item, say here. See what we're working with, right? Always like to do that. So sweet. Okay, so that helps a ton. We have that to work with, and then we can just append that, right? If node maps to none, append the full path of that node to the list. Interesting. Otherwise, extend the file list with the results calling the list files on the node. Okay, so I imagine we need to do that split deal. So current node, but I don't know if we can do that on a, we say paths that append item, right? And then reappend paths. And then if we could check if item equals none, return the paths, right? I think that's kind of what we want, right? Kind of a bit. So that feels almost right. It's just the current node situation. I don't think we can do this action right here, but that does feel almost correct, right? So let me just let's try this. Unhashable type slice. That's what I was thinking. You can't do that with a dictionary. So what if we just did this and just appended until the path came out, right? Maximum recursion depth exceeded in comparison. Okay, so that's not going to work. So how do we get the first object of a dictionary, or the first key of any dictionary? How do you do that? Is it this? Oh, okay. Well, let's look at the solution then. So if node value file list is none, so for node in current node, node values equals, I see. So if node value is none, file list append. This hurts my brain, guys. This one hurts the brain. This one hurts the brain for sure. Okay, so the file list is an instantiated just dictionary, or list, excuse me. We're looping through the current node, getting the node. We're setting the value, which is going to be the key within the node, is set to the, so we're doing the opposite. We're setting the values of the node first. I'm trying to understand this, right? We're checking if the node value is none. Oh, that does make sense. Okay, so that's how we get the key from the dictionary. Okay, which we're using as the value to append as the path. If the path is this, boom, return the current path plus the node, because that means it's the end, right? Else keep building the list. So extend the list is what they're doing. I didn't know you could do that. Just append. Okay, so clearing it out, gonna try from the brain. So let's say paths. We'll just instantiate it as this. That makes sense in my brain. So we'll say for node in current node. What was it? It was the node values, right? So that the key value storage, we're gonna figure out the values real quick, which is gonna be the current node by the node. If the node is none, we want to, what was it? Paths append. Basically, we want to return the paths, right? So paths append, we want the node value plus the slash sign plus the node, right? And was it return the paths? Return the paths was always at the bottom, right? So that's the first bit. Now the second bit was a little bit more tricky. I don't even remember it, to be honest. My brain's not there. So let me think it through. So we want to extend on this list. So we could say else maybe, right? Else paths append. Or no, we need to do recursion, right? So list files, and we want current node be at the node value. Was that what it was? Current node. Extend. It was the current node at something, right? The current node, current path maybe? Nope. Okay. What would this be, right? I gotta peek at the solution one more time. Okay, so we have the list. Okay, so it's the current path plus the actual name here. Okay, so node values. Where did I miss? Return file list, if, else, boom. So the node value. It's not the current node, but that does kind of make sense. I mean, it's still the same value, right? Yeah, it is. Okay, so, if node values is none, that's what it is, not the node. Is none not equals, so that's a difference there as well. But that seems about right, everything else. So I'm just instantiating a thing called path stated file list. I'm saying for the node in the current node, the node values equals this node, right? If that value is none, append the current path. There we go, that's where I messed up. Plus the node. Okay, cool. Golly, recursion. What makes it hard to loop over a tree? Well, just all of it, for starters. You don't know how many levels there are. That's certainly one of them. Loops are hard for my smooth brain. That was my initial answer. What the heck, Bhutan Dev? What the heck? Shots fired. Trees has too many items in the initial list? No. It's going to be, we don't know the depth of how far. So imperative loops are allowed in purely functional code. No, they're not. Had to learn the hard way there. Loops are often by good programmers are often used by good programmers even though they break the academic rules of functional programming. Yeah, that's probably true. Cool. All right, so we're in the challenge bit already. Well, I shouldn't say already. It's taken a half hour to get here, but we're in the challenge bit. So let's see. In doc.dot, we might have documents nested inside other documents forming kind of a tree. It's crazy how docx files can get. Anyways, we want to find out how deeply nested a given document is. Complete the count nested levels function. It should recursively search for the target document ID in this nested document dictionary and return the number of nested levels in that document. Okay, so the function shouldn't, if the target document doesn't exist. So let's see, if, is that how you do it in Python? If none, boom, like that, right? Is none or undefined, right? Maybe that'll work, right? Just if it's none, do that. If not, it should look for the document. So for nested document in nested documents, we want to see if it equals that ID, right? But before I go there, let me just see what we're getting at for the levels again, the documents. So nested, or what data we're given. Target, and let's see the level of these things, right? Okay, so we have a target is 3, the level is 1, and these are the nested documents. So it needs to stop at the third document is what I'm understanding. So if the target document doesn't exist, we want it to return none. Expecting 3, actual none. Okay, so I think that helps, right? So if target document is none, we might have to do something there. But for nested documents, let's see what's this all about, right? So let me print this nested document real quick. Nested doc, boom. Let's see, 1 is a nested doc. Okay, perfect. So that is, we need to return the number of nested levels that thing is. So these may be on different levels. Got it. So the input here is actually the document ID, and we want to return the level that that document ID is on, which right now it's 3 for this example, but it may not be such. May not be such. Okay, so that is tricky. That is tricky to think about. So if the document is, we're given this big object, and we want to search if nested document equals target ID, right? So if nested document equals target document ID, we want to return the current level we're on, right? If that is not the case, we need to go 1 level deeper, which means we probably want to do some sort of recursion. So if not, we want to get the nested document key. So that's going to be the thing here, I believe, right? And then we still look for the same target ID, but then we want level plus equals 1. I think. No? That felt right. That felt right for my smooth brain. Okay, so let's see. So if document in nested document, oh, we probably needed that base case. So for document ID, where does it get document ID? Oh, right here in nested documents, boom. So that's just what we did right here. If nested document, so that works. Return the level. So we have that bit of logic there. They just did a base case external of this. I just did a guard clause kind of deal, which I think either is roughly appropriate, right? So okay, so return -1, great. If not, this is the thing. Getting a little bit. Oh, okay, so that was good. So nested documents, nested document, great, right on the money. Level +1, maybe that's what we needed. And this bit, if found level. So rough idea. The rough workings were there, just not fully executed. So if found level does not equal -1, so meaning it's not this, then we are in the gold. Okay, not terrible, not horrible. If found level, what is found level? Oh, this whole thing is found level. Okay. Yeah, recursion hurts my brain. Being honest, recursion hurts my brain. But I'm going to sleep on it tonight. My brain's going to absorb it all. It's going to be great. I'll wake up just knowing all of recursion and everything about string theory in physics. It's just all going to work. Okay, so reverse a string. Oh, this is going to be fun. Reverse a string. It should take a string as a parameter and just reverse the input. So print S. Okay, so Python is the expected output. So we could also do, I think Python does have a reverse thing, but we're going to do it the proper way, the recursive way. So I think what I want to do is, I think I need an array. So I'll say reversed string is an empty list first, so I can store the string in that list, or I need a dictionary. I think either could work. Let's split this